All right, and our final problem for today is a little bit tricky. It says the element indium exists naturally as two isotopes. Indium-113 has a mass of 112.9043 AMU, and indium-115 has a mass of 114.9041 AMU. The average atomic mass of indium is 114.82 AMU. We are asked to calculate the percent relative abundance of the two isotopes. But the trick in this problem is that we are given the weighted average. We are told what the weighted average is. We're told that it's 114.82 AMU. This time we're asked to calculate the relative abundance of each of the two isotopes, which is where the tricky part comes into play. What we need to recognize is that the sum of the percent abundances, so the percent abundance of the first isotope plus the percent abundance of the second isotope, must equal 100%. Or all of indium. Or another way to think of it, the percent abundance of the first isotope plus the percent abundance of the second isotope has to equal one whole, or all of the indium that's out there. So to solve this problem, let's say the percent abundance of that first isotope, indium-113, is X, and the percent abundance of the second isotope, indium-115, is Y. We're going to use some basic algebra skills here to solve for Y. So Y is equal to 1 minus X. I'm going to grab this formula again, and using what we just set up here, plug the numbers into the formula for the weighted average. Again, we recognize that the weighted average is given to us in this problem as 114.82 AMU. And again, that's given to us here. The mass of the first isotope is 112.9043 AMU. And we used X to represent the percent abundance of that first isotope. We're going to add to that the mass of the second isotope, which is 114.9041. And we're going to multiply that by its percent abundance, which we labeled Y, or 1 minus X. Okay, so now we just have to use some basic algebra skills to solve this. We're going to rewrite simply 112.9043 X times X. And then we're going to add to that, and then we're going to distribute the 114.9041 through this expression here. So we're going to get 114.9041 minus 114.9041x equals our weighted average of 114. We're going to combine like terms here to give us negative 1.9998. X plus 114.9041 equals the 114.82 AMU. We're going to subtract the 114.9041 from either side, 9041, to give us negative 1.998x equals negative 0.841. Then to solve for X, we simply divide each side by negative 1.998. X then equals 0.0421. Woo! We solved for X, but what does that mean? What did we set that up for again? What is X? If we take a look back up here at the top, we said X was our percent abundance for that first isotope, indium-113. Percent abundance of that first isotope equals X, which we solved to be 0.0421, and in percentage format that would give us 4.21%. To get the percent abundance of the second isotope, we determined that to be Y, or 1 minus X, which will give us 0.958 or 95.8%. And so here are your final answers. Our relative abundances for the two isotopes. For isotope 1, in our case indium-113, percent abundance is 4.21%. Percent abundance for the second isotope, indium-115, is 95.8%. And as we think about whether or not that makes sense, the weighted average mass is 114.82, which is really close to the mass of that second isotope, indium-115. So it makes sense that that's the more abundant of the two isotopes.